Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about integration by substitution.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, the integral of 20x sine of 5x squared minus 3 dx, and we're given a u value of 5x squared minus 3, and we have to evaluate this indefinite integral. Now luckily for us, they gave us the u value already. So let's go find our du value. Du, the derivative here, power rule, 2 times 5 is a 10. And we have the x to the first power, and then constant's gone, dx right here. Okay, so now let's go see if we can rewrite this in terms of, well, u and du, and we're very close. Clearly my u value is inside of sine right here, so a u value right there. And then my du, well, it's almost there. We have a 10x dx, but here we have a 20x. So if I pull out a 2 outside of the integral, I'm left with a 10x sine of a 5x squared minus 3 dx. And again, now we have our u and du's lined up. Our u value, again, is just inside of what's inside of sine, and our du is a combination of the 10x and the dx. So we can rewrite this in terms of u to be 2 times the integral of sine of u du. Now this is a much easier problem to solve. The integral of sine, okay, the integral of sine is a negative cosine. So we have negative cosine of u, and then we have a plus c. At this point, we just have to plug in our u value back in here. So we have a negative 2 out front here, times the cosine of our u value, which is, in terms of x, 5x squared minus 3 plus c. And there we have it. Our final answer here is a negative 2 cosine of 5x squared minus 3 plus c. We're given this problem right here, the integral of 16x to the third power minus secant squared of 4x to the fourth power minus 2 dx. And we're given a u value of 4x to the fourth minus 2, and we have to evaluate this indefinite integral. Well, since we're already given a u value, let's go find our du value. Du right here, taking the derivative, 4 comes down, multiplied by 4 is a 16, x to the third power, ignore the minus 2 now, and we have a dx afterwards. And now we want to see if we can rewrite our integral in terms of u. And it lines up pretty well, actually. Our u value here is that 4x to the fourth minus 2, easy to see. And then we have a 16x to the third dx. These two are our du. So we can rewrite this in terms of u to be the integral of the secant squared of u, and then du. That's it. Not too bad. Now this one's a much easier integral to solve. The integral from our identities of the secant squared of u is the tangent of u, and then plus c. Alright, so at this point it's actually really easy. We rewrite this, we have a tangent, and instead of u we plug in what was given for us as u. 4x to the fourth power minus 2, don't forget the plus c, and there we have it. Our final answer here is a tangent of 4x to the fourth power minus 2 plus c. We're given this problem right here, the integral of 6 times e to the 3x power times the cosine of e to the 3x power minus 5 dx, and we're given a u value of e to the 3x minus 5, and we have to evaluate this indefinite integral. Now we're given the u value, so let's go find our du. Du here is equal to, well, the derivative of e to the 3x minus 5. E to the u will be u prime, so the 3 comes out front, times e to the 3x power. Minus 5, don't worry about it, and then we have a dx afterwards. Pretty simple. So now we want to see if we can rewrite this function in terms of u and du. And we're kind of close. Clearly, our u value is what's inside of the cosine, right there. And our du is very close to this, right? We're only a little off. We have a 3 here as a coefficient, and here's a 6. But if I pull out a 2 from the 6 to be outside of the integral, I'm left with a 3 e to the 3x power times the cosine of e to the 3x minus 5 dx. Now from here, it lines up pretty well. we have the u right here, and then here, the 3e to the 3x dx is my du, combining the two. So now we can write this in terms of u. 2 times the integral of cosine of u du. Now, keep on going. Let's go integrate this. Okay, let's do it over here. 2 times with the integral of cosine of u is just sine of u plus c. Now, we need to plug u back in. So we have 2 times the sine of u being e to the 3x minus 5. Then we have the plus c, and that's our final answer. A 2 times the sine of e to the 3x minus 5 plus c. We're given this problem right here, the integral of 50x over the secant of 5x squared plus 5 dx, and we're given a u value of 5x squared plus 5, and we need to evaluate this indefinite integral. Now we're given a u value already here, so let's go find our du value. Du here is equal to the derivative, 2 comes down times 5 to the 10, x dx. That's it. All right. Well, we want to rewrite this in terms of u. Now, clearly this inside the secant is our u value, but our du doesn't really line up perfectly. We have a 10x dx, and here we have 50x dx. If I pull a 5 out of my integral here, I'm left with that 10x dx we're looking for. So I do that. I have the secant here of a 5x squared plus 5 dx here. And now we can see the direct substitution going on here. Again, inside the secant is our u, and our du is that 10x dx. So let's go write this in terms of u. So we have 5 times the integral of, well, 1 over the secant of u du. Now, if you're like me, I don't really want to write 1 over secant. So 1 over secant is the same as the cosine, right? So we can rewrite this to be 5 times the integral of the cosine of u du, and that's a much easier integral to solve. The integral of cosine is sine, so we have 5 times the sine of u plus c here, and then we just need to plug u back in. U goes in here, 5 sine, u is that 5x squared plus 5, and don't forget the plus c. So our final answer here, if I can kind of cut it off here, is a 5 times sine of 5x squared plus 5 plus c. We're given this problem right here, the integral of negative 36x to the third power secant of 3x to the fourth plus 3 times the tangent of 3x to the fourth plus 3 dx. And we have to evaluate this indefinite integral. Well, the first thing I want to do is find a u value here. And when picking a u value, I try to find what I see a common of inside of my trigonometric forms, right, or functions, right? And I'm going to choose a 3x to the fourth power plus 3. So let's go find a du from here. 4 comes down times 3 is a 12, x to the third power, and then we just have a dx there. And it looks like we're pretty good, we're pretty close to what we have out front. We see a u can be here, inside here, and a u can go in here, and we're pretty close with the x to the third dx. We just have a 12 and a negative 36. If I pull out a negative 3 from this integral, I'm left with a 12x to the third power, and that shows up what we need. So let's continue with this out, secant of 3x to the fourth plus 3, let's show all of our work here, times the tangent of 3x to the fourth power plus 3 dx. And again, inside here, we have our u values. Pretty easy. The 12x to the third and the dx make up that du value. Okay? So let's go write this now in terms of u and du. Negative 3 comes down here still. Integral of the secant of u times the tangent of u now. And instead of dx, or 12x to the third power dx, we just have a du here. Well, what's the integral of secant of u and tangent of u? And if you remember the definitions, that is just the secant of u plus c. So we have now the -3 times the secant of u plus c. That wasn't too bad, right? Well, it's going to plug in our u back in, right, in terms of x. So we have a -3 times the secant, and instead of u, I'm plugging in that 3x to the 4th power plus 3. And don't forget that plus c right there. And so our final answer here is -3 secant of 3x to the 4th power plus 3, all plus c. We're given this problem right here, the integral of -9 times the secant of -3x times the tangent of -3x times the secant squared of the secant of -3x dx. And we have to evaluate this indefinite integral. Well, I want to find a u value here. And this one's a little tricky, right? Normally, I would gut feelings like, oh, maybe a -3x, but I don't think that's really going to work out for us here. I actually found the integral here, or the u value that works, is that secant of -3x. Just think about that for a moment. If we had a u value of just -3x, I would have a u here, a u here, a u here, and then, to be honest, what would we do here? What's going on? We have -3, might line up with a dx, we have to pull out a 3, but we still have a lot of u's and we're not really going anywhere. So if we try with the u being secant of -3x, what's my du value? Well, the du value, derivative inside, will be -3, that's like the u prime. Then we multiply that by, well, the secant of -3x times the tangent of -3x dx. That is a fairly large du, but it actually lines up pretty good for what we need. So again, let's go see if we can get this thing kind of similar. Notice right here, we have our u value, and our du lines up pretty well. We have the dx here, tangent of -3x, secant of -3x. I just need a -3 out front. So if I pull out a +3 from the integral, I'm left with a -3 on the inside, secant of a -3x, a lot of writing here, tangent of -3x times the secant squared of the secant of a -3x. I'm done with these secants, dx. Now we can substitute things in our u values, right? So our u is right here, and our du is this -3 secant of -3x, tangent of -3x, and my dx together is my du. So we can rewrite this now to be a very easy integral to solve. The integral of 3 times the integral of the secant squared of u du. Now that looks way more manageable. So the integral of, well, the secant squared of u, so we have 3 times the integral of secant squared of u, if you know our definition, that's just the tangent of u plus c. And then from there, we just have to substitute u in. So u are 3 times the tangent, and instead of a u, let's put that secant of a -3x in there for u plus c, and there we have our final answer. 3 times the tangent of the secant of -3x, all plus c. We're given this problem right here, the integral of a -5 cosine of -4 plus natural log of 4x, all over x dx. And we have to evaluate this indefinite integral. Now, we want to find a u value here. And I'm going to pick what's inside of the cosine. -4 plus the natural log of 4x. Right there. Okay? I'm going to write a plus sign. There we go. Well, with that, we need to find our du value. Well, derivative of -4, don't worry about it. 0, get rid of that. Now, natural log of 4x will be 1 over 4x times the derivative of the inside, which is a 4 dx. Hopefully you see the 4's cancel, and we have 1 over x dx as our du. Now we're pretty close here. Notice we have a -4 plus natural log of 4x. That's our u value. And our du is 1 over x dx. We're almost there. We just have that pesky -5. But we can pull that outside of the integral. -5 times the integral of cosine of a -4 plus natural log of 4x all over x dx. And now this is pretty easy to see. Again, our u value is right here, and here we have our du value. Okay? We have du right down there. That 1 over x dx. Well, now we can substitute u and du in. So we have a negative 5 times the integral here of the cosine of our u value. And then instead of a dx and a 1 over x dx, we just have that du that goes right in there. From there, well, what's the integral of cosine of u? Well, it's sine of u, right? So we have negative 5 times the sine of u plus c. Don't forget the plus c. I almost did. Then from here, we know what our u value is, negative 4 plus natural log of 4x. So we plug that in. We have negative 5 times the sine of a negative 4 plus natural log of 4x. Then the plus c on the outside. Don't forget it. So again, our final answer here is a negative 5 times the sine of a negative 4 plus natural log of 4x plus c. We're given this problem right here, the integral of 4x to the third power over the cosecant of x to the fourth minus 1 dx, and we need to evaluate this indefinite integral. Now I first need to set a u value, and I'm going to pick what's inside of the cosecant, that x to the fourth minus 1. If that's that, then our du, taking the derivative, 4 comes down, we have 4x to the third power, then just a dx. And this actually works out in our favor pretty well here. Notice we have a u value that's inside here that we set, and our du is a combination of the 4x to the third dx. Pretty simple. So now let's go write this in terms of u and du. Well, the integral here of 1 over the cosecant of u, and then, well, the 1 just is a place value, and the 4x to the third dx is our du out here. And you can put the du on the numerator if you wanted to. Well, then from here, I actually like to rewrite this cosecant to be, well, 1 over cosecant of u to be sine of u, right? So we have the integral of the sine of u here, du. Not too bad. Well, what's the integral of sine of u? Well, the integral of sine of u is negative cosine of u du. Oh, sorry, not du plus c. I always do that. Oof. So the integral of sine of u du is a negative cosine of u plus c. Then from there, we just plug our u back in terms of x, right? So negative cosine of, instead of u, x to the fourth minus 1 plus c. So again, our final answer here is a negative cosine of x to the fourth power minus 1 plus c. I hope this video was helpful, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.